Hello, math champions. In this video, we're going to learn to prove a circle theorem. Okay. And as we always do in our channel, we first learn why we are learning all of these. Okay. What is the necessity to prove the theorems that some mathematicians already proved? What is the benefit for us? We may not use the theorem, we may not use a circle, we may not do the things given in this theorem in our daily life. Then what is it that we are learning? What is it the necessity to learn? The important thing about theorems is that when you are proving these theorems, you will be giving reasons to it. When you're giving reasons to it, your reasoning ability gets improved. Okay, your reasoning ability gets improved, and this reasoning skill is one of the important skills to lead your life. For example, if you have to choose a particular decision or a particular path, you need to give reasons to yourself or others also. Or if you have to decide between two things or three things, you need to give reasons. Okay, this is the reason, this is the reason, this is good, this is the reason, this is good, this is the reason, it's not good. And when you're able to give such reasons, you'll be able to take decisions very well. And for that, you need reasoning ability. And that is developed when we are proving these theorems. Okay. Just like any process, reasoning process also, we have to have a certain steps to follow. So now a theorem is given. What's the first step is read the theorem, understand it, and draw a diagram for it. So here the theorem says an angle in a semicircle is always a right angle. That means what? First of all, there is a semicircle. For the semicircle, first we need a circle, right? So we draw a circle. And next thing we need is a semicircle. Semicircle means it is cut into exactly to half. And this is the diameter, correct? Diameter, and this is our center. O is our center. And let's say this is AB is our diameter. We have this diameter, we have a semicircle. Now what do they say? The angle is there. So we need to make an angle in that semicircle. Okay. So we are going to make one angle in that semicircle. Okay. We did this. It became an angle now. So not only an angle, it became a triangle now, right? Where all the vertices are on the circle. And this one of the vertices is one inside the semicircle. So this much is there. But what is it that you have to prove is they're saying this angle is always a right angle. What do you mean by right angle? Right angle means it's 90 degree. That means they're asking us to show or prove that this angle that we have marked here, that is going to be 90 degree. So first step is we write what all is given to us. We write what is given to us. AB is diameter, correct? AB is diameter because that's a circle. And what else can we write? What else do we know? AO or BO, whatever, right? AO is equal to BO is equal to, it's a radius because all the radii inside the circle are equal, correct? So these are all things, the properties of circle we know. And ACB is a triangle. That's all we know, correct? ACB is a triangle. It's a triangle. These are the things we know. First, we have to know what is given to us, right? Then next, what do we have to prove? We have to prove that this angle C, that means angle ACB is equal to 90 degree, right angle. This is what you're going to prove. So next, we go for our proof. The steps with which we take to prove. Now, before we go for a proof, just with this, do we think we can do anything? No, because you cannot use any other reasoning. But one thing we can do is if we can do some other extra construction, we call this point as a construction. So we are going to do a construction. Construction is apart from what is given in the theorem. We are going to do something extra drawing also. What is it I'm going to do? I am going to draw another radius. That's all. Why? Because if radius is there, what happens? I'll get one more triangle using which I can do many things. So I'm going to connect the radii. Okay. Radius OC. Okay. I'm going to connect OC. Now, OC is also a radius and OC is equal to OA because it's the radius again. Okay. It's the radius. So I know this. So I do this construction. Why? Because in that way, if you see, in this triangle, OA is equal to OC, it becomes an isosceles triangle. So now I can use the properties of isosceles triangle also. That's my trick, basically. So next, I'm going to prove. So what's the proof? So as I told, the construction I have done to get an isosceles triangle so that I can use the properties of isosceles triangle. So what I'm going to do is, let's say the angle C is entire C, angle C only I have to find out, no? So what I'm going to do is I am going to take this part inside that isosceles triangle. I'm going to give a name to it as X. Okay. So I'm going to say let angle ACO be X. Okay. Let ACO be X. Now, if that is X, okay, we know it's an isosceles triangle. So, this will also be X. Correct? So, I know, so that what happens? CAO is also X. Now, let means I have assumed, but the next statement CAO is X. I have to give a reason. Very important. That's what I told. It is going to improve my reasoning ability. Why? How can I say CAO is equal to X itself? Because a triangle ACO is an isosceles triangle. I write this reason. Very important to write the reasons. Isosceles triangle. So because of that, I know this is a isosceles triangle. Now, next thing is we know two interior angles. Two interior angles we know. So what we do is okay, is there something we know about interior angles and exterior angles of a triangle? Yes. What is that we know? We know that the exterior angle for this triangle. What is the exterior angle? The exterior angle is angle COB, right? That's the exterior angle. So I have shaded it for you to understand which triangle I'm observing. I'm observing that triangle, shaded triangle. So as of now, I'm going to remove the shading. And so I know that external angle is COB. We know that the external angle is equal to the internal opposite angles. That means angle ACO and angle CAO. Why? Again, reasons we have to write. Exterior angle is equal to the sum of interior opposite angles. That is the reason I can say this. Okay, so what happens? Angle COB becomes equals to x plus x. That is 2x. Okay, now I have got something like this is 2x. So now I have another triangle now, which is an isosceles triangle. Which is the triangle? It is this triangle. I'm shading it here. If you see here, this is an isosceles triangle again. What do we know? Isosceles triangle means, again, which are the equal sides? This is equal to this because these two are radii, right? These two are radii. So I can say that angle OCB. Okay, I want you to observe where is OCB. This is OCB. This OCB, let me write in blue color. Okay, this OCB and OBC, these two are equal. Correct? These two are equal because it's an isosceles triangle again. So, angle OCB is equal to angle OBC. We know because the reason is it's an isosceles triangle. Reason is isosceles triangle. What are I doing here? We are only using isosceles triangle, and now next we are going to use angle sum property. So in the triangle COB, what is happening? I know that all the sum of all three angles is going to be 180 degree, no? I know the sum of angles is going to be 180 degree. So, what happens? This angle OCB will be equal to, okay, equal to angle OBC, that is also equal, that will be equal to 180 degree minus 2x. Means I'm going to subtract the third angle. And because they're equal, it is each angle is going to be half. Correct? So that gives me 90 minus x. Right? It gives me 90 minus x. Oh, so now I got to know this angle is 90 minus x. I'm going to continue the proof this side. Okay. I'm going to continue the proof here. So what happens? I came to know that OCB is 90 minus x. Now it's just a matter of finding out what is the entire angle, the black color angle C. That means angle ACB is equal to angle ACO added with angle OCB. ACO, we know it's X, red color, and OCB is the 90 minus X, which is the blue color, right? When I add these two things, I am getting 90 degree. So that means angle ACB is 90 degree, which is what we wanted to prove and which we have proved. Hence, proved. Right? Hence proved. Now, for this thing last year, we had not written the proper reason, right? So let's write. This is angle sum property of a angle sum of a triangle. That's the reason, correct? If I'm adding these three angles, it's going to be 180 degree. But each angle, other two angles are equal. So one of the angles will be 180 minus the 2x divided by 2. And therefore, I'm getting that 90 minus x. And finally, we came to know that angle ACB is a 90 degree. So this is how we prove a theorem. And proving the theorem by giving reasons improves our reasoning ability. Okay. And I hope you enjoy this video, and I hope you enjoy even learning geometry and enjoy giving reasoning, because remember, that is going to develop your problem solving ability even for life. Okay. See you until the next video. Bye-bye.